Hello everyone, welcome to new class. Today's class is about
Eigenvalues and eigenvectors.
before going through eigenvalues and eigenvectors, we have to learn about characteristic equation. So what is characteristic equation? Let A be a square matrix, then determinant of A minus lambda I is equal to 0 is called the characteristic equation. And here I is the identity matrix and lambda is an unknown scalar. So this is called the characteristic equation. Then what is eigenvalues and eigenvectors? So the roots of this characteristic equation are called eigenvalues. That is the value of lambda is called eigenvalues. Then what is eigenvectors? Eigenvector is represented by x. So eigenvector of a square matrix A is a non-zero vector x such that when A multiplies x, then the result is just a scalar multiple of x. So this one we can write a minus lambda into I into x is equal to 0. So in this a minus lambda I is called, that is determinant of this one is called a characteristic equation. Here the eigenvector x is a non-zero vector which is corresponding to the values of lambda and which is called the eigenvector. So eigenvector means it is a non-zero vector x corresponding to the eigenvalues lambda of this equation, that is a minus lambda I equal to 0. So eigenvector is a non-zero vector x corresponding to the eigenvalues of the characteristic equation. Then note that if A is a 2 by 2 matrix, then characteristic equation is lambda square minus trace of A into lambda plus determinant of A is equal to 0. That is, after finding the determinant of A minus lambda I, we will get like this. That is, it will be lambda square minus trace of A into lambda plus determinant of A is equal to 0. Then what is trace of A? Trace of A is the sum of diagonal elements of A. Then if A is a 3 by 3 matrix, then characteristic equation is equal to lambda cube minus trace of A into lambda square plus S into lambda minus determinant of A is equal to 0, where S means it is the sum of cofactors of diagonal elements of A, or it is called the sum of principal minors. So S is sum of cofactors of diagonal elements of A or sum of principal minors. Next is properties of eigenvalues. Let A be a square matrix, then sum of eigenvalues of A is equal to the sum of diagonal elements of A, that is the trace of A. So sum of eigenvalues of A is the trace of A. Then product of eigenvalues of A is equal to the determinant of A. So product is equal to determinant of A. Then the eigenvalues of A and A transpose are the same. Then fourth one is, if any of the eigenvalues of A is 0, then A is singular. Then fifth one, eigenvalues of triangular matrix is equal to the diagonal elements. So whether it is upper triangular or lower triangular, the eigenvalues of triangular matrix is equal to the diagonal elements. Then sixth one is if lambda 1, lambda 2, etc. lambda m are the eigenvalues of A, then eigenvalues of A raised to n are lambda 1 raised to n, lambda 2 raised to n, etc. lambda m raised to n. Then seventh one is if lambda 1, lambda 2, etc. lambda m are the eigenvalues of A, then eigenvalues of A inverse are 1 by lambda 1, 1 by lambda 2, etc. 1 by lambda m. That is the reciprocals of the eigenvalues of A. So these are the properties of eigenvalues. Let us do a problem. Find the eigenvalues and eigenvectors of matrix A is equal to 1, minus 2, minus 5, 4. So our first step is to find the eigenvalues. So we have to find the characteristic equation. So characteristic equation equal to determinant of A minus lambda I equal to 0. So for that, here we have to write A minus lambda I, that is A is 1, minus 2, minus 5, 4, then minus lambda I, that is lambda 0, 0, lambda. So first of all we have to find A minus lambda I. So here we will get 1 minus lambda, minus 2, minus 5, then 4 minus lambda. So this is A minus lambda I. So here we have to only change the values of diagonal elements, that is 1 minus lambda here, then here 4 minus lambda. Now we have to find the determinant of this one, that is determinant of A minus lambda I is equal to, so here we can cross multiply this one, that is 1 minus lambda into 4 minus lambda, then minus 5 into minus 2, that is 10, which is equal to 0. That is here 1 into 4, 4, then plus lambda square, then minus lambda, minus 4 lambda, that is minus 5 lambda, minus 10 equal to 0. That is here we will get lambda square minus 5 lambda minus 6 equal to 0. So this is the characteristic equation. So here we can find that this one, that is the coefficient of lambda is negative of the sum of diagonal elements, that is minus 1 plus 4, and this negative 6, that is negative 6 is the determinant of this one, that is determinant of matrix A is equal to 4, then minus 10. So this is determinant of A. So using the properties of eigenvalues, we can find that the coefficient of this lambda is the negative of sum of the diagonal elements, and this one, that is product, is determinant of the matrix. So what is the roots of this equation? So this is negative 5 and this is negative 6. So we can factorize like, that is lambda minus 6 into lambda plus 1. So lambda minus 6, that is the product is negative 6 and the sum is negative 5. So the factorization of this equation is lambda minus 6 into lambda plus 1 equal to 0. So what is the value of lambda? So lambda is equal to negative 1 and plus 6. So this is
The eigenvalues, that is the eigenvalues are
negative 1 and 6. Now we have to find the eigenvectors corresponding to this lambda. So now we have to find the eigenvectors corresponding to these eigenvalues, that is eigenvector x corresponding to this eigenvalues lambda is the solution of the equation A minus lambda I into x equal to 0. So here we have to find the solution x. So for that we have to put the values of lambda here. So lambda equal to -1. Then we can find a minus lambda I into x equal to 0 here. So a minus lambda I is this one. Now put the values of lambda here. So 1 plus 1, that is 2, then minus 2 minus 5, then 4 plus 1, that is 5. So this is a minus lambda I into x. So x is the solution. So this is 2 by 2 matrix. So here x is x1 and x2. So this is a column matrix and this is equal to 0. So it is 0 matrix, that is we can write it like this. Now here we have to find x1 and x2. So by finding the rank of A, that is by the Gauss elimination method, we can find the solution of this one. So for that we can find the rank of this matrix A. So for that let us do the operation. R2 implies, let us make this element 0. So R2 implies 2 times R2 plus 5 times R1. So after doing this one, we can make this element 0. So that is 2 minus 2, 0. Then here also we will get 0 because here signs are interchanged. Then into x1 and x2 equal to 0. Now here this row is 0. So what is the rank of this matrix? So rank of this matrix is equal to the number of non-zero rows, that is 1, and the number of unknowns are x1 and x2, that is 2. So rank is less than the number of unknowns. So here we have to assume value for n minus r variables. So n minus r variables, that is n minus r is 2 minus 1, that is we have to assume value for one variable and then find x and x1 and x2. So from this equation we can write 2x1 minus 2x2 equal to 0. So let us assume x2 is equal to k. Then what will be x1? So 2x1 equal to 2x2. Then x1 is equal to k. So x1 and x2 is equal to k here. So the solution is when lambda is equal to -1, x is equal to x1 and x2, that is equal to k and k. And if k is equal to 1, so if k is equal to 1, then we can write this as 1 and 1. So the solution of A minus lambda I into x equal to 0. That is the eigenvector corresponding to the eigenvalue lambda equal to -1 is 1, 1. Now we have to find the eigenvector corresponding to the eigenvalue 6. When lambda is equal to 6, then this equation A minus lambda I into x equal to 0 becomes, this A minus lambda I is 1 minus 6, that is minus 5, then minus 2 minus 5, then 4 minus 6, that is minus 2 into x. So x is x1 x2 equal to 0. Now here we have to find the rank of this matrix. So for that, let us make this element 0. That is R2 implies R2 minus R1. So here we will get minus 5 minus 2, 0, 0 into x1, x2 equal to 0. And here, what is the rank of this matrix? So rank of this matrix is equal to 1. So rank is equal to 1 and the number of unknowns are 2 here. So here also we have to assume value for n minus r variables, that is 2 minus 1, that is one variable we have to assume value. So this one we can write minus 5x1 minus 2x2 equal to 0. So let x2 is equal to k. Then we will get minus 5x1 equal to 2x2. Then x1 is equal to 2 by minus 5 x2, that is minus 2 by 5 k. Let k equal to 5. Then x2 will be 5 and x1 will be minus 2. So the eigenvectors corresponding to 6 equal to x1 is minus 2 and x2 is 5. So the eigenvectors corresponding to the eigenvalues minus 1 and 6 are x equal to 1, 1 and x equal to minus 2 and 5. So in this way we are doing the problems to find the eigenvalues and eigenvectors. So in the next class, let us discuss more problems related to this eigenvalues and eigenvectors. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.